Also the resistor, and the resistance decreases.
So it's one kind of resistor, right?
Yes.
That behaves like this. When light falls on it, then resistance decreases. That's called light dependent resistor. Where we use light dependence resistor in our last class, we gave you some discussion on it. Where we are using this light dependent resistor. Can you remember, anyone? Hello? We use light dependent resistor in street lamps, right? Then intruder alarms. In our last class, if you go through the recording, you will get it. We discussed it. So where we use light dependent resistor? Hello?
Road lamps.
Then intruder alarm, right?
Yes, sir.
Yeah. So we are starting now. Topic 19, 17, 18, 19, 20. So it is 20, right? Topic 20, DC circuits. You write the topic name, topic 20, DC circuits. At the beginning of DC circuits, we have some circuit symbols. You see the circuit
So should
symbols
we
are
draw
given.
them all?
You have to. You have to
Okay,
draw
sir.
them all because we gave you this list from the learning outcomes. If you go through the learning outcomes, you see we here you see draw circuit diagrams with power sources, cell, battery, or AC mains. That means here we have three: cell, battery, AC. AC mains, and after that we have switches, closed, open, mode 2. Then resistors, fixed and variable, mode 2, 7. The light dependent resistor, 8. Then 9 thermistor, lamps, 10. This way, whatever is written here, all these symbols are available there. We did not give you any extra symbol, which are mentioned in the syllabus learning outcomes. We only gave you that. That's why you have to know them. Okay?
Okay, sir.
And during Cambridge exams, you will be only assessed on this symbol, not more than that. Okay, so here you go. We have all the symbols together. Now, my question is why we are using these circuit symbols?
Sir, to determine the objects in the circuit more easier.
More easier. That's the most appropriate phrase you used, more easier. That means more comfortable, more easier, more effective, right?
Yes, sir.
Because like you are here, five students present. Then if you see the real circuit, then lamp, you see different kinds of lamps, different shapes of lamps, right?
Yes, sir.
So if your house you have one kind of lamp, you are drawing in one way, another person will draw in another way. Even the same lamp you have, that time also we have variation of drawing style, right? Isn't it?
Yes, sir.
That's why we use a common circuit symbol to make our communication, presentation more easier, effective, and comfortable to each other. Is it clear
Yes, sir.
why use the circuit symbol? And not only in our batch, in the country, all around the globe, everyone can communicate easily, right?
Yes, sir.
One person in another state or country, you can communicate with the same circuit symbol without any hesitation, right?
Yes, sir.
Okay, so you have your switch open, switch closed. Then cell battery. Cell is the unit of power supply, fundamental unit of power supply, that is cell. If two or more cells connected together, that's called battery. Okay,
Okay, sir.
then diode is a device or appliance which allow the current to flow in one direction. That's why diode is known as rectifier.
Okay, sir.
Then variable resistor, already you know the resistance can be varied. That's called variable resistor. The resistance value can be varied. That's called variable resistor. You finish drawing, then we will write uh, some of their definition. Okay,
Okay, sir.
we know most of them. Few they are known, they are not known to you. Those we only just define.
So done drawing.
Drawing is done, mashallah. Then here you write beside cell. We have drawing. We have a bit more. Maybe next page we have little more to see. We have this also, right? So we will
Yes.
do them, no problem. But we finish this part first. Then we have cell. Besides cell, you write fundamental unit of power supply. Yeah? Fundamental or basic. You can say basic unit of power supply. Then battery. Where is Lamisa? Hello.
I don't know, sir.
Could you please take the information? Where is Lamisa?
Okay, sir, I'm knocking her.
Okay, now look here. We are going for two or more cells more cells are connected together. Yeah, Monica. Hello, Monica.
Yes, sir.
It's topic 20. Yeah, DC circuit. You write the topic name, then you write this circuit, draw the circuit symbols, and also write the short definition. I'm giving you short definition. This short definition will help you to recognize them, which are them, and you can make the difference. What is the difference between cell and battery? And then diode, we have diode that it allows the current to flow in one direction. It allows the current to flow in one direction. Okay, fuse. This uh, device which protects the circuit or part of circuit from overflow of current. If current is high, if current is high, then fuse melts and this is a device which protect the circuit or part of circuit from overflow of current. If current is high, the fuse melts and disconnect the circuit. So you understand what is fuse, right? Hello?
Yes, sir.
Yes, sir.
Any problems, anyone, to
No,
understand
sir.
it?
No, sir.
Okay. It's a
Sir, I
device.
called Lamisa, but she didn't pick up.
Okay, okay, no problem. You just leave her a message that we are in the class. You please join. Sir told you to join. Huh?
Okay, sir.
So Here we are done with fuse. Then we have another device, that is thermistor. It's one kind of resistor. We had LDR. You know about LDR. LDR is related to light. Okay. So you already told me what is LDR. LDR is related to light. Okay. Hello.
Yes, sir.
LDR is related to light. So when light is more, then resistance decreases. When light falls on the resistor LDR, and then it resistance decreases. Similarly, thermistor is related to heat or thermal energy. If the temperature is more or heat is more, then resistance decreases. Resistance decreases, right? So electricity gone in my house. That's why they are searching for charger light
Okay, sir.
and my tiny torch. Okay, so thermistor, you can define is one kind of resistor which on which if the temperature or heat is more, then resistance decreases. If temperature or heat energy is more, resistance decreases. Okay, it's one kind of resistor, right? When you see light dependent resistor, thermistor, and you see fuse, they all have the similar symbol of resistor, isn't it? Hello, see, resistor, huh? If you are giving one arrow over this resistor, it becomes variable resistor. If you join the lines, both the sides, it becomes fuse. Then thermistor, if you are drawing a line, so they all are one kind of resistor, isn't it?
Yes, sir.
So uh, thermistor is also one kind of resistor whose resistance changes depending on the heat or temperature. Is it clear?
Yes, sir.
Okay, so a variable resistor, you know, right? What is variable
Yes.
resistor? The resistance can be varied. The resistor whose resistance can be varied. That one is variable resistor. So you write here variable resistor resistance can be varied. Yeah. You write the bottom part of the symbol, that's better. I'm writing for your convenience so that you can see it. Resistance can be varied. Resistance can be varied. Okay.
Okay,
Hello.
sir.
Till here, any questions, anyone?
No, sir.
Okay, if you don't have any questions, then we will go for next. So you got before diode, right? Here,
Yes, sir.
diode, if you are giving two arrows outwards, that's becoming LED or light emitting diode. Okay, so here you write beside LED light emitting diode. It's one kind of diode. If electricity passes through it, then it emits different color of light. You see LED screen, right? LED screen
Ye-
we have for
yes, sir.
television, for laptop or any other monitors. We have the displays, advertising displays in the streets, right? Roads, highways. Those are also LED, right? Different kinds of light are coming out through this light emitting diode. If electricity passes through light emitting diode. Okay, light emitting diode, AC voltage source, that means alternating current, alternating current. You got little idea about alternating current in magnetism, where we use the idea of demagnetization, right?
Yes, sir.
There we got that if we are using alternating current, then we are having demagnetization of the magnet. Alternating current. What is alternating current? That means normally in the DC direct current we have the current flow in one direction, but in alternating current we have the current flow in both the directions, from left to right or right to left. In 1 second it alters 50 times, 100 times, 150 times, this way. That's called alternating current. And alternating current uh, is is the you know is the current or is the source which is helping us to get the voltage varied using the transformer. We can use the transformer to increase or decrease the voltage. Like the grid line, we have the voltage, high voltage, right? Very high voltage in grid lines. Do you know it? Hello?
Yes, sir.
So when this is transferred to our house, we are using transformer to get the high voltage to lower voltage. Okay, that time we are using transformer, and you see in different places the electric poles. And there is big infrastructure over there, uh, metal made, right? Metal made,
Ah,
curved, and big, huh? Huge. Those are actually transformer to make the voltage lower to our house. And for application of the transformer, we need AC voltage. Otherwise, transformer will not work. More
also, I
details.
have a question.
Yeah, sure.
Sir, who invented transformer?
Uh, he's actually this one is made by, so far I can remember, we have few scientists involved with it, yeah, not a single one. And finally, um, Wersted, Wersted, he gave the idea, okay, about the transformer.
Okay, sir.
And then Henry, he also contributed. And DC circuit, firstly, it was mostly used by Thomas Alva Edison, and afterwards, the people I told the names, they they gave the idea of this uh, modification and updated applications of AC voltage transformer, all these things. Is it clear?
Yes, sir. Do you know?
So it's actually the development of science is not the, it sometimes happens that it's the continuation of uh, effort of many people, right? Not a single person, isn't it? And one
Yes, sir.
part is done by one person, another part is done by another person. This way it goes. Okay, then we
Sir,
have we
understood.
have some other scientists, Maxwell. They have also here contribution in the electromagnetic induction, electromagnetic effect. Okay.
Okay, sir.
Hmm. So here we have bell. Bell means electric bell. That one you very much familiar with. You have this idea. Now transformer, you just write here. You will get more details in about transformer in topic 23, electromagnetic induction. AC voltage also will be discussed over there. AC voltage transformer will be discussed in topic 23. So here you write, uh, it's a device, it's a device to modify modify magnitude of voltage. Modify magnitude of voltage. One example I gave you that transformer can be used to make the voltage lower from higher to lower. We can do that is called step down transformer. And sometimes we also need to get the higher voltage, like when from power station to grid line we give the voltage, that time we need to make the voltage bigger, because grid lines is a long distance, and to transfer electricity in these grid lines we need to have higher voltage, otherwise there will be power loss, energy loss. More details we'll get later. Now only get the idea. We have step down transformer where we have the lower voltage from upper voltage, and also we can have step up transformer from lower to higher voltage we can convert. Is it clear? So
Okay, sir. Understood.
what about others? Have you understood this discussion?
Yes, sir.
Okay. So simply we know transformer that it's been used to modify the magnitude of voltage. It can be higher to lower or lower to higher. When it is higher to lower, it is step down, and when it is lower to higher, it is step up transformer. Two kinds of transformer are there. Okay, now magnetizing coil, you already got it in topic 17. You got right hand grip rule. There we use DC current, direct current. So there we got that if electricity passes through a coil, then we have, according to right hand grip rule, we have magnetic field produced, right? North pole and south pole we get, isn't it?
Yes, sir. Yes, sir.
So that's magnetizing coil. So I close the window so that the
Sir, it's fine. You can continue.
dog is barking outside. Okay, now relay. Relay is a one kind of device. Uh, that one we are using. You saw one circuit that in topic 17 you will got that circuit that if one circuit is on, then other circuit is off. You got one question like that, like there was a magnetizing coil, and when the magnetizing coil it was off, then the bell rings. Can you remember you got a question like this? Hello, hello.
Yes, sir.
Can you remember that one? I can show you that now. Otherwise, some of you not understand. Here we go. Relay comes from the relay race. Have you heard about relay race?
Sir.
No, sir.
In athletics, there is one event. Uh, like normally we have 100-meter sprint, 200-meter, 500-meter or more. A single person is uh, competing, right, with other persons, isn't it? But when this race is becoming like a team, like in your team you have three athletes together, you are completing 300 meters. Then other team, 300, another three persons. So you will go 100-meter and you will pass a stick to your next teammate, and then the rest of the 100, rest of the 300 meters, 100-meter is rest. That one is will be run by the last person, third person. This way we are completing the race. That is called relay race. Now you understand what is called relay race.
Yes, sir.
Hello everyone, you understood?
Yes, sir.
Yes, sir.
Okay, so relay race is done by more than one person. Similarly, when we are having one circuit uh, is helping other circuit to be run, to be switched on or switched off, and then this combination is called relay circuit. Is it clear now? Hello?
Yes, sir.
Yes, sir.
So there is more than one circuit involved to have the system, complete system or complete arrangement of the appliance. That is called relay circuit. So we show here we have one that is in electricity and magnetism, Topic 17. This one, huh? The first question we had in the test. So here you see we have two parts of the circuit, right? So when this battery is not working, or they are saying battery P is disconnected, then what happens? If battery P is disconnected, that means we don't have any current here, the upper circuit. If the upper circuit does not have any current, then this iron core will not be magnetized, right? It is demagnetized, isn't it? Hello? Hello?
Yes, sir. Yes, sir.
Okay, so if this iron core is demagnetized, that means it will no more attract the iron armature. Iron armature will, drop down, right? Isn't it?
Yes, sir.
So when the iron armature is going down, that time the lower circuit is on, and this bell rings. So this upper circuit is helping the lower circuit to be switched on or off, to get the bell rung or not. Is it clear? Hello?
Yes, sir.
Yes,
That's
sir.
why this arrangement is called a relay circuit. So you draw these circuit symbols. Have you drawn all this?
Yes, sir.
Okay. So all the circuit symbols are done. Relay, you understand that more than one circuit are working together. That is called relay circuit. You write there, more than one circuit work together. That calls relay circuit. Okay, you join at 8. Come back at 8. Thank you.
Thank you, sir.